Alright, this is a quick video of the extra multiple choice questions for the MAT for 2020. So, for this one, the easiest way to do it is using a rule for Pythagoras for cubes. That's my Pomodoro timer, guys, sorry. X, and the rule is, if you want to find, we know that the opposite corner, so this is 2. The easiest way to do this is just x squared plus x squared plus x squared equals 2 squared. So 3x squared equals 2 squared, x squared equals 4 over 3. So, and then once you got x squared, you know one face, so, and you know there's 6 faces, it times out by 6, and you get 8, so C. If x is a very large positive real number, then the product, well, I looked at pairs, so we know that 2 to a very big number over 3 to a very big number times 4 to a big number. Well, this is always going to be bigger, a lot bigger, and because we times it and then this is the final pair, the bottom is always a lot bigger, so it's very close to 0, because x is a very large positive real number. C, using degrees, the number of real solutions x to the equation. So we know that cos is like this, and the solutions of cos a equals a half is 60, 300, and then obviously you have like minus 60 and minus 300. So I tested these. So 240x equals 60x squared plus 4 divided by 60, you have 4x equals x squared plus 4. That is x minus 2 squared equals 0, so that's one solution. And then I was like, oh, let's try minus 60, it'll probably be similar. You get 4x equals minus x squared minus 4, so it turns out x squared plus 4 plus 4x, which is x plus 2 squared. So we already know it's one of these. Test 300. So this is like, first thing I did, test values. You divide by 60. So 4x equals 5x squared plus 20. So 0 equals 5x squared minus 4x plus 20. I was like, don't know how to solve that. I mean, I could, but first I was going to put it in my new quadratic formula. So I was going to check b squared minus 4ac just to check. So b squared minus 4ac to check the discriminant, so to see if it does have real solutions. So it's 16 minus 4 times minus 400. Well, that is very negative, and because it's less than 0, there are no real solutions. And if you test minus 300 as well, you get no real solution. So there's only x equals 2 and x equals minus 2 at a real solutions to this. It's only C. So D, you have y equals 2x plus 3x squared plus 5x cubed. And so the coefficient of x to the n is the nth prime number. Then the value of the fifth derivative at x equals 0 is... So that's just... I wrote down a few more terms of this. You have to watch out because the coefficient of x is the nth prime number. It's not just... so 7x to the 4 plus 11x to the 5 plus... and then if you take the derivative of that, you get 2 plus 3x plus 5x squared plus 7x. Oh, my bad, guys. That's just wrong. You get 2 plus 6x plus 15x squared plus 20x cubed. I'm trying to work too fast. That's the first derivative. And if you set that equals 0, then what's the value of the first the first derivative? If you set it equals 0, then it's just equal to 2. So that's 1. Then if we did that 2, 3, 4, 5 times, we want to find what that value will be. So for this one, it's 2. That's 1. That's 2. That's 3. That's 4. This is 5. So the only thing we actually need to differentiate is this term. So it goes 55x to the 4. Then it's going to be just times that by 4. So 220x to the 3. Times that by 3, 660x squared. And then you have 1320x 20 plus all these x plus x squared, ax squared plus bx plus, yeah. And then you set this one equal to 0, and that's the answer. So E. The curve is sketched, so when I looked at that, it kind of looks like a circle, but not. It looks like a weird circle. If that was plus. So I just test x equals 0, give minus y to the 20 equals 1, so y to 20 equals minus 1. Well, there's no solutions for that. So D. Yeah, that's it. So I got this one wrong. I found this one quite difficult, like reciprocals and all that. But there's a good trick where you just times by x plus 2 squared, because I mean you could times by x plus 2. I mean, yes, both times by x plus 2, but then you'd have to consider cases for when x plus 2 is negative or when x plus 2 is positive, which is just a bit tricky. So instead, if you times by a positive number, x plus 2 squared, then you get by difference 2 squares. I'm just going to do it into one step. X plus 2 is less than 0. So you get a cubic. And then let's do the same here. 1 minus x squared. You get 1 plus x, 1 minus x is greater than 0. So let's sketch them both. So we got minus 1, 1, minus 2. It's positive. Yeah, it's positive. So you've got something looking like that. Minus 2 versus minus 2. And when is this less than 0? All of this. So when x is less than minus 2, or when x is greater than minus 1, less than 1. This is just a quadratic. Root of 1 minus 1 is negative. So it's like this. So when is it greater than? Well, between 1 and minus 1. So this P implies Q because it implies this. However, Q does not imply P. So P implies Q, but Q does not imply P. Okay, question G. I quite enjoyed this one. If you S to 0, you're literally just getting 1, 2, 3, 4, 5, 6. If you apply S a load of times. If you apply T loads of times, let's see what happens. So T of 0 is minus 1. T of 0 equals minus half minus 1. So minus 3 over 2. T of 0. I mean, right, so all rational numbers greater than minus 1. Not that already, right? So we just need to see if it's greater than minus 2 or all of them. So let's try another one. Equals half of this, so minus 3 over 4 minus 1, so which equals minus 7 over 4. Let's apply T again. Minus 7 over 4 half, so minus 7 over 8 minus 1 equals minus 15 over 6. Minus 15 over 8. So if we do T to 5, 0 equals minus 15 over 16 minus 1. Well, this is just going to keep going. And it's never going to... The powers of 2 are going to increase, but this is never going to get bigger than 2. So, yeah. So, T. Okay, so H, sequence A. I like this question. This is very nice. So A of 0. I just like to have like a few terms. A squared, because a to the 4, a to the 8, a to the 16. This is what this is saying. Okay, 0 of 0. And then, so B is linked to this. We need to find out if it's one of those. So B is log 2. So log 2 a to the n. So log 2a is just 1. Well, there's log 2a. Log 2a squared. So log 2a, log 2a squared, log 2a to the 4. And you can write these by log laws as 1, and just a number, because log 2a is a number. 2, log 2a, so that's just a number. 4, number, because where b equals log 2a. So you've just got a number, then times by 2, times by 2. Oh my gosh, what's that? That's a geometric progression. So see. Oh, I found this one hard, and I think it's a generally a really tough question. 2 its vertices are 0, 0, and 1,000, 0. And I know equilateral triangles are in the ratio of 2 root 3. Or in the ratio, if we take that in a half, in the ratio of 1 root 3, 2. So instantly, I'm like, oh, this is 1,000, this is 500. Oh my gosh, this is not what I meant to do. Okay, and then this, I instantly was like, that's 500 root 3. And I did 500 times this. I found it easier to do 173.21, just like change where the 100 is. And I multiplied it out, and you get 866.05. Yeah. And then, so this number is this point here. So this is 866.05. Well, that means that the point, it says inside the triangle, so none of the triangles on the outside. So this point is 866. And the key to this question is thinking, well, how many points would be in a cube? 1,000 and 1,000. Well, it's about 1,000,000, if we're including the edges. So take away like 4,000 because of all those edges. So it's just under 1,000,000. Well, this triangle is about half. So it can't be more than half of this, because we have to take away the edges. So it's going to be D or E. And now, I look at D and E, and we're not going to... I don't want to work that out. That's a pain. So let's just try and think about what's the difference between these two numbers. Well, this one's even, this one's odd. So if we can distinguish the number of points inside this is even or odd, we know the answer. So what was key here, I found, was we've already got this as 866, it's height. And we know that by symmetry, this side is going to have an x number of dots inside. This one is going to have an x dots inside, plus this line. So we've got 2x plus 866. So that's an even plus an even. That is horrific handwriting, but you see what I mean. An even plus an even. Oh, that's also an even number. So I've got D. J, this is our last question, and it's these look scary, but luckily it's just, these have just been, X has just been changed for Y. So it's a reflection in line Y equals X. It's just nice reflections to know. So first I sketched these two, I set them into equal to Y, and they just look like things we already know. Oops. So y equals x squared minus 2, and y equals minus x squared plus 2. I'm going to do a nice big sketch here. I think this is going to be very hard to sketch, but I'm going to do my best for you. Minus 2, 2, x squared minus 2 looks like this, x squared plus 2 looks like this, and these are root 2 and root 2 because of, yeah, and then we need to do the same, but it's just a reflection in this line, and y was x. So we can just draw these two by doing the reflection in the line y was x, and that is going to equal 2, no, root 2, so it's going to be smaller, like this, and then something like this. I'm sorry about that horrific drawing, but this is 2, and this is minus 2, and this is root 2, and this is minus root 2. And then you've got this, like, area in the middle that you want once you work out all the inequalities. You know, it's this area. Now, how do we find out which one of it is? I actually thought about a circle, right? Because these edges are, the maximum points are root 2 away from the origin. So the maximum area would be a circle, x squared plus y squared equals 2, because obviously that's r squared, centered origin. So what's the area of a circle? Well, we all know that. It's pi r squared, so it's 2 pi is the maximum. So if that's the maximum, this area could be, well, at least close to it, then it's not going to be that one. It's not going to be that one because that's about 9 point something. I don't know if it's 7. Bigger than 9. This is bigger than 9. This is a lot greater than 2 pi. Can't be infinite. It's not going to be 0, so D. And that's how I did these questions. There's also, you can just integrate here because you can notice that both lines go through 1, 1, like they go for a 1, 1 or a minus 1, 1 or twice. So these are points where curves intersect. So you've got a cube here of 1. No, 4. And then you've got these little triangles you can work out by integrating. But I'm going to be late for my bus, so I'm going to say goodbye there. Feel free to integrate between, that's root 2, 1 and root 2. 1 and root 2. And it's, yeah, one of these curves minus the other one, dx. Integrate. Should work out that, but that's way too long for a multiple choice question, but you can just work this out. So, yeah. Guys, that was 2020 maths extra multiple choice. I hope you enjoyed that.